grade 8 learners, welcome to another math lesson which is all about inductive and deductive reasoning. At the end of the lesson, you are expected to define inductive and deductive reasoning, differentiate inductive and deductive reasoning, and apply inductive and deductive reasoning in an argument. But before that, let's have a quick review of what you have learned in your previous lesson. Last time, you have learned about converse, inverse, and contrapositive statement. All you have to do is to convert the conditional statement, which is if an animal barks, then it is a dog. Convert the if-then form to its corresponding converse, inverse, and contrapositive statement. Okay, you may start now. Okay, the converse statement is, if an animal is a dog, then it barks. How about its inverse? So we will have, if an animal does not bark, then it is not a dog. And finally, the contrapositive, if an animal is not a dog, then it does not bark. I hope that you refresh your minds with your previous lesson. Mathematical reasoning is a critical thinking skills that enables someone to make use of all other skills in mathematics. There are two common types of reasoning, which are inductive and deductive reasoning. Let's have first inductive reasoning. Inductive reasoning is defined as, or it is, uses specific example to arrive at a general rule, generalization, or conclusion. It is a process of coming to a general conclusion from seeing patterns in specific examples and looking for the regularity in those patterns. In short, we draw a conclusion based on a specific examples or event. To understand more about inductive reasoning, let's have an example. Inductive reasoning includes visual patterns. Take a look at the figure in number 1. What do you think is the fourth figure? Very good! As you can see, each circle is divided into twice as many equal regions as the figure number. Sketch the fourth figure by dividing a circle into 8. Shade the section just above the horizontal segment at the left. Next, we have, in the sequence 10, 20, 30, the next term is 40. Again, inductive reasoning allows you to make a general rule from a specific example. Like in number 2, you are given sequence with first 3 terms are 10, 20, and 30. From this example, you may conclude that the sequence of number are divisible by or multiple of 10. Therefore, you can conclude that the next term is 40. Let's have another example. For number 3, John, a math challenger, is good in mathematics. Joanne, Josh, and Pia, who are also math challengers, are good in mathematics. Therefore, all math challengers are good in mathematics. In example number 3, you are given specific names of math challengers, John, Joanne, Josh, and Bea, who are good in mathematics. From this specific example, we can conclude that all math challengers are good in mathematics. For number 4, the chair in the living room is red. The chair in the dining room is red. Therefore, the color of the chairs in the house is red. We can conclude that all chairs in the house are red as you observe that the chairs in the living room and dining room are red. Another type of logical reasoning is deductive reasoning, wherein it uses basic and or general statement to arrive to a conclusion. This reasoning which allows you to make a specific conclusion based on general truth or facts. So, let's have an example. For example number 1, Sally does not drink soft drinks. Then it follows that she does not drink cola. Deductive reasoning starts from a general statement or fact to conclude into a specific example or claim. So for number 1, you are given that Sally does not drink soft drinks. Since a cola is a specific example of soft drink, then it follows that Sally does not drink cola. So let's have another example. For number 2, right angles measure 90 degrees. Angle A is a right angle. Therefore, angle A measures 90 degrees. In example number 3, you are given a general statement that right angles measures 90 degrees. Knowing that angle A is a right angle, then the conclusion is angle A measures 90 degrees. Let's have another example. Number 3. All mathematics challenge contestants are good in mathematics. Jim, Jane, and Jillian are math challenge contestants. Therefore, Jim, Jane, and Jillian are good in mathematics. In example number 3, it provides a general statement that all mathematics challengers are good in mathematics. Since Jim, Jane, and Jillian are mathematics challenge contestants, then we can specifically conclude that Jim, Jane, and Jillian are good in mathematics. Very easy, right? Just remember that inductive reasoning starts from specific information to draw a conclusion based on a carefully gathered information, while deductive reasoning deductive reasoning starts from general statement to conclude into a specific examples or claims. At this point, I know that you are ready to answer our activity for this lesson. So, all you have to do is to draw conclusion from each given situation and identify the kind of reasoning used. You can pause and play this video while trying to answer each item. Okay, learners, you may start now. Okay, let's reveal the answers. For number 1, we have the next number is 25, and it is inductive reasoning. For number 2, x, y, and z are on the same plane, and it is deductive reasoning. For number 3, we have Belen is equilateral, and it is also deductive reasoning. For number 4, the child may say, all teachers are ladies, and it is inductive reasoning. And for the last item, Julia is a peace-loving person, and it is deductive reasoning. Did you got a perfect score? Excellent! You are really paying attention to our discussion. I hope that you have learned a lot from our lesson for today. That's all for today. See you next time. Keep safe and God bless.